Hi guys, this is your favorite math teacher, DKA. And today we're looking at trigonometry ratios and their rules. Trigonometry ratios and their rules. Now, first of all, let's look at the trigonometry ratios and their reciprocals. So, trigonometry ratios. Ratios and their reciprocals. Now, trigonometry ratios and reciprocals. Now, first of all, we have the basic trigonometry ratios, which is our sine, you have cosine, and you have our tangent. And some of the textbooks, they have shortened it to sine. You see, sine that is written like this, maybe of certain angle, let's say alpha, maybe cos alpha, then maybe tan alpha. Now, we are going to look at their ratios. So let's look at this. Before we look at this, let's say we have a diagram with a circle like this. And let's say we have a certain value. Here is the center. And we know that from the center, any part of the circle is our radius. From the center to any part of the circle is radius. So let's remove this as our arm, radius. And you know this one is always x. And this one is always y. And this is always our x in Cartesian field. Now, if the whole of this line is x, and this one is y, so let's bring this y here. So, with this, we are going to form, let's say we have a triangle with it. So let's say this one is our y. And let's say from this side to this side, this is our angle. This is the alpha. The angle alpha. Angle alpha. And now in trigonometry, we measure anti-clockwise. We measure from the 0 degrees, we measure backwards. That's called the anti-clockwise direction or anti-clockwise measurements. Now, we have triangle here. And in which we have, let's say, here is forming a perpendicular to the baseline, this is x. So, or it's forming 90 degrees. So, as you can see, we have a right angle triangle here. And from this, we can apply the idea of Pythagoras. This is that the hypotenuse square is equal to the sum of the squares of the two other sides. So from here we can see that r squared is equal to x squared plus y squared, according to the law of Pythagoras. Now, let's look at these signs. Let's use the idea. So we have sine. Let's apply this. It's called so. Then we have cos to be cap. Then we have turned this to 12. This thing is going to help us to reduce the ratio for them. So these are the basic trigonometry identities. So these are identities. So we have talked about the trigonometry identities here. Identities. We have cos, that's cosine. Then we have sine. Then we have the tangents. These are normally we use them to be identities. But their ratios is now what we are going to look at. So when you take so the first letter is S, which is not to draw this one, which is sine. So sine of a certain angle, so this angle we use sine equals to opposite. Now we have a triangle here. Now the line which is facing the angle is called the opposite. The line which is facing the angle is called the opposite. As you can see, that the angle here is facing this line. So the line here, which is y, becomes our opposite. And adjacent line. So we also be looking at the adjacent line. This is the adjacent line. The adjacent line is the line that joins the opposite line to form a 90 degrees. So as you can see, you have two lines joining the opposite line. As each one joins the opposite line to form the 90 degrees, is the base line here, so which is x. So if you take the which is sine, it becomes sine of the angle equal to the opposite. O stands for opposite. So as you can see here, this line is opposite. Here is our axis. Then here is our the hypotenuse. So sine, which is the first letter, sine. Put opposite, which we have here, opposite over hypotenuse. Then let's look at which is what? Cosine. Which in short form is cos. So cos alpha equal to which is A here stands for what? Adjacent. So adjacent over hypotenuse. The H, which is what? Hypotenuse. Then we also check T, which is tangent. So tan of the angle which is equal to the next letter is O, which is what? Opposite. Over then the last letter is what? A, which is what? Adjacent. So over adjacent. So as you know, let's say sine is equal to opposite over hypotenuse. Cos is what? Adjacent over what? Hypotenuse. Then tan is what? Opposite over adjacent. So these are the ratios. Now let's see. When it comes to sine of alpha, now opposite here is what? Y. So we put our y there. Over hypotenuse. What's our hypotenuse here? Which is what? R. So we put our R there. Now let's take also cos. So cos alpha equal to cos is what? Adjacent. What is the adjacent? Which is labeled to what? X. So adjacent equal to cos adjacent, which is x over hypotenuse. What is hypotenuse? R. Then tan alpha, so which is opposite, the opposite is what? Y. Over adjacent, which adjacent also is what? x. So these are the basic trigonometry ratios you know. So these are the ratios of these three basic identities. We also have their reciprocals. We also have these three. So these are the main basic trigonometry ratios you know. These are the three main basic trigonometry ratios we know. So, as the thing was drawn like this, then we have our r, our x, we have our y. So, their basic ratios, we have 1 to be seconds of the same angle, cotangents of a certain angle which is alpha. Then we have cosine of the same angle. Now these are their basic or their reciprocal. So these are the main, these are the ones that then their reciprocals are this. Now we are going to look at how to use those the ratio for these three too. Now, in doing this, always the first two letters you analyze them. You take these words and these two letters are the word that makes the other basic identities reciprocate. So, for instance, if I take seconds, I have to consider the first two letters. Then I have to take the first two letters out. So if I take second, I have to take the first two letters out. So I have to analyze the first, then consider the third letter. So what's the third letter here? Which is C. So C means we are dealing with cos. So meaning second is the inverse of cos, or is the reciprocal of what? Cos. Are you okay? So if you take the first three letters out, then you consider the third letter, and you come and check which of the three identities starts with C. So when you come here, it is cos or cosine. So meaning this second here is the reciprocal of this. And when you say something is reciprocal, let's say 2. The reciprocal of 2 becomes half. Why? Because this one is over 1. If I reciprocate it, it becomes 1 over 2. So the reciprocal of this is equal to 1 over cosine. Let's consider cotangents. So if I analyze the first two letters, then I consider the third letter. Then I go, the third letter which is T, which represents what? Tangents. So meaning cotangent is the reciprocal of what? Tangents. So this is also equal to 1 over tangents. Then, if I take the next one, which is cosine, I have to consider the first two letters. I have to analyze the first two letters, then consider the third letter, which is x. Then I'll go here to the first two identities and check which one starts from x, which is sine. So this becomes 1 over what? sine. Now, if that's so, let's put them. Now, we know 1. So let's take this one. So seconds is equal to 1 over cosine. But what is cosine? Cosine is cos. And it has a ratio x over r. Meaning seconds is equal to 1 divided by x over r. Therefore, seconds equal to 1 times r, because if you want to move the division sign, then we reciprocate this r over x. Therefore, we have our seconds alpha equal to r over x, because 1 times anything gives the same thing. So as you can see, he said seconds is the reciprocal of what? Cos. And here, as you can see, cos is x over r. And when we come here, we now have now gotten second to what? R over x. So it's as reciprocates what? Cos, a ratio. Now let's consider cotangents. Cotangents. Alpha. Cotangent alpha, he said, is the reciprocal of what? Tan. So this is y on x. This simply means 1 divided by y on x. So we are going to have 1 times x on y. So this is equal to x on y. This is called the cotangent, meaning cotangent alpha. Cotangent alpha is x over y. So as you can see, cotangent has interchanged the ratios. It has reciprocated the ratio, the variables. Now let's consider the last one. Let's consider the last one. Which is cosine. So cosine, as we said, is a reciprocal of what? Sine. So this is 1 over sine. So the sine ratio is y over r. So this simply means cosine is equal to 1 divided by y over r. Therefore, this becomes 1 times r over y. Therefore, cosine is equal to r over y. So, these are our what? Basic 6 ratios, or basic so these are the identities or the basic ratios and their reciprocals. So basically we have 3 basic ratios, or 3 basic ratios and their reciprocal, which makes 6. Now from here, we are going to look at sine, trigonometry sine, trigonometry ratio sine, trigonometry ratio sines, or the signs of trigonometry ratios. Signs of trigonometry ratios. Signs of trigonometry ratios. Signs of ratios. So we look at signs of trigonometry ratios. Now, yeah, in this diagram, we have 4 sections. We have the first section, we have the second section, we have the third, we have 4. Now, we said this is called the first quadrant. First quadrant. Then you have the second quadrant. Then you have the third quadrant. You have the fourth quadrant. Now, this thing is going to help us to understand which basic ratio is negative at a certain point. At a certain point, which one also is not negative. Now, as I said earlier in trigonometry, we measure anticlockwise. So we start from the origin, which is 0, then we move to the next. So in every section, we add negative to it to get to another section. So here, if I want to get to this, I have to add 0 to here is 0, so I have to add 90 to it in order to get to that section. So if here, if I want to get to this, I have to add 90 to this. If I add 90 plus 0, I'm going to get 90. If I have 90 to this here, I want to get to this, I have to add another 90 here, which becomes 180 degrees. If I'm also here, if I want to get to this, I have to add 90 to this, which becomes 270 degrees. Then if I have 270 degrees, if I have to get to this, I have to add 90, which becomes 360 degrees. Now, at this stage, in the first quadrant, all of the basic ratios are positive. So, sine is positive, cosine is positive, then tan of a certain angle, they are all positive here. When it comes to the second quadrant, sine is positive, cos is negative, then tan also is negative. If you come to the third quadrant, sine is negative, cos also is negative, then tan is positive. If you come to the fourth quadrant, sine is negative, cos is negative, cos is positive, sorry, and tan is negative. Now we are going to prove and see whether it is true or not. Now, all that we are trying to say is that you have 0 to 90, 90 to 180, 180 to 270. All that we are trying to say is that we said here all of the basic ratios are positive. So meaning from 0 to 90, every value you take, and you take either tan or sine or cosine of that angle is positive. So for instance, if I take any value here, from here to here, let's take 50. So if you take 50, so let's say cos 50 tan 50, then sine 50, because this 50 is found within 0 to 90. All the answers supposed to be what? Positive. So for instance, cos 50 is 0.34, good carrying 8 and go on. So let's say it's 9. If you take tan, of the same value, so tan 50, so you get 1.19175. Then let's say sine 50, also 0.76604. And as you can see, because that value was taken in between 0 to 90, if any basic ratio, whether the reciprocal or the main grade, all of them supposed to give you a positive answer, because they said within the first paragraph, all the 3 basic ratios are positive. Now, from 90 to 180, only sine is positive. So for instance, let's choose any value between 90 to 180. You can have 100, you can have 91, you can have 120, you can have 130 and above. So far as it's within here, only sine is positive. So let's try sine 120. So let's say sine 120 cos 120, then tan 120. So let's put them and see. So if you take sine 120, so sine 120 is giving us root of 3 on 2. Let's type cos 120, which is negative half. Let's take tan 120, this is negative root 3. As you can see, the second quadrant says sine is positive as all the rest of the identities are negative. So since in the second quadrant it starts from 90 to 180, any value that you take from that side, we are supposed to get only sine to be positive, and that's what we have proved over here. And then the second third quadrant is from 80 to 270. Only tan is positive, the rest are negative. So you can take any value between 180 to 270, as well as you can consider maybe the value 200. So let's say sine 200 cos 200 tan 200. So far as it's within the same range, and you know that the answer only term is what? Positive. So let's see. When you have sine 200, it's given as negative 0.042. When you have cos 200, we are having negative 0.9396. Negative. It's negative 0 point. Then when you have 200 is 0, it's given as 0 point. Given as 0.3639, which is positive. And this one is given as negative. So as you can see, in the third paragraph, only term is positive. Then, let's consider the fourth paragraph. The fourth paragraph from 270 to 360, only cos is positive. So let's take a value like 300. So we take sine 300 cos 300 and 300 and see which one is positive there. So if you take sine 300 is negative 1. So as you can see, in the fourth quadrant, only cos is positive and the rest are negative. So these are the signs. So whenever you are pointing, check the number, whether the number falls within the first quadrant, the second quadrant, and know which one is positive or negative. So that's all about the sign of trigonometry ratios. Now, without wasting much time, we move on to another subtopic, which is special angle. When we end there, next time we meet, so for now we are going to check special angles. Special angles. Special angles under trigonometry ratios. So we look at special angles. The special angles just simply, let's say I have this, the same thing. So from here to here, as you know, here is 0 degrees, here is 90 degrees, as you know. Now you want to see, and you know, from on the y-axis in trigonometry is sine, and then the x-axis here is cos. As we are going on, I will explain to you. Now, what that they are saying is that if I take special angle, let's talk about any of the two values. If I take within any particular range for sine and cosine, and then if I add the two values, and it gives me the sum of that particular the sum of that particular angle within that quadrant is called special. For instance, if I take 0 plus 80, which will give me 90. So these are the special, meaning all that we are saying is that if I take sine 0 and cos 0, cos 0, cos 0 degrees, it is equal to sine 90 degrees. Because if I sum these two values, it gives me the highest sum of that quadrant. Are you okay? So for instance, let's take, because I said in trigonometry, measure anti-clockwise. So let me see. Let me measure a certain angle here, let's say 30 degrees. 30 degrees. Now, as you can see, from the S to the angle of measure is 30 degrees. So, which means the S value here is 30. So, if I take cos 30 degrees, which value should I add to the what? The y-axis or the sine line? That will give me 90 degrees. Which means what will be added to 30 to give me 90, which is what? 60 degrees. And if I add sine, meaning cos 30 degrees is equal to sine 60 degrees, because if I add 30 and 60, I'm supposed to get the highest value of that quadrant, which is what? 90 degrees. So that is if I point on the calculator, cos 0, it is 1. If you point sine 90, which is also 1. Point cos 30 is root 3 on 2. If you point sine 60, which is also root 3 on 2. You can as well as come to this side. To this side, we always take the accused value of the S and then this value again. So here we know from here to here is 180 degrees. Then let's assume if we measure this side to be 60 degrees on the cos axis or the S axis. Therefore, we can say cos 60 degrees is equal to, from here to here. From here to here will give us what? So what will be added to 60 to get 180, which is 120. So what's sine 120 degrees. But note, here cos is what? Negative. So you have to negate this before you punch. So meaning negative cos 60, this is giving me no, so that this value they will negate it, sorry. So you just take it like that. So we are going to get half. Then we punch sine 120. Okay, which also is giving us different values, so we have to check this very well.